A real-world example using fluid mechanics principle would be an airplane. The part we are looking at in this video is the airfoil. The principle used here is Bernoulli's principle. Let's look at the forces being applied here. A fluid flowing past the surface of a body exerts a force on it. Lift is the component of this force that is perpendicular to the oncoming flow direction. It contrasts with the drag force, which is a component of the force parallel to the flow direction. Lift conventionally acts in an upward direction in order to counter the force of gravity, but it can act in any direction at right angles to the flow. An airfoil generates lift by exerting a downward force on the air as it flows upward. According to Newton's third law, the air must exert an equal and opposite force on the airfoil, which is lift. Bernoulli's principle states that there is a direct mathematical relationship between the pressure of the fluid and the speed of the fluid. So if one knows the speed of all points within the airflow, one can calculate the pressure and vice versa. For any foil generating a lift, there must be a pressure imbalance, lower average air pressure on the top than on the bottom. Bernoulli's principle states that this pressure difference must be accompanied by a speed difference. Bernoulli's principle ultimately became the basis of the airfoil, the design of the airplane wing when seen from the end. An airfoil is shaped like an asymmetric teardrop laid on its side, with the fat end towards the airflow. As air hits the front of the airfoil, the airstream divides, part of it passing over the wing and part passing under. The upper surface of the airfoil is curved, however, whereas the lower surface is much straighter. As a result, the airflow over the top has a greater distance to cover than the airflow under the wing. Since the fluid has a tendency to compensate for all objects in which they come into contact, the air at the top will flow faster to meet the other portion of the airstream, the air flowing past the bottom of the wing when both reach the near end of the airfoil. Faster airflow is demonstrated by Bernoulli, indicates lower pressure, meaning that the pressure on top of the wing keeps the airplane afloat. Now it'll be a quick video of how the airflow actually works, a quick animation. Thank you for watching.